Hey Claire, thanks for joining me as part of this teacher training. I'm really glad to be able to sit down with you and get some insight in how you ran the Mission to Moon program with your students.
Yeah, I'm really excited to talk about it. It's been an amazing experience, and it's great to now be on the teacher side of this now that I helped with the training, helped create some of the videos. So those of you watching may recognize me from that, but I hadn't actually taught the curriculum until now. So uh, let's get
Yeah,
into it.
and so the teachers are watching all these training videos and they're learning about these different platforms like Flipgrid and Goose Chase. They're learning about the different engineering challenges, but I thought it would be useful to show or to talk about how you actually put this in the classroom. And so I want to note here that you were running this as an in-class program. And so this is going to be really good information if for any teachers are running it in the classroom. So can you just kind of walk us through what was a typical week like for Mission to Moon?
Sure. So I use the Space Club programming through from fourth grade through sixth grade. I teach them twice a week for 45-minute class periods each time. So it was pretty quick that I had to jam pack all this information in, but it worked really well in the classroom in person. I did a lot of the different activities in teams, which worked really well. And so I'll kind of break down how that looked with each lesson. So we would meet on Tuesdays and Thursdays for 45 minutes each. The first class period of the week, I would show them the intro video and then the video for each mission. And then to follow that up, we would start brainstorming and doing the design part of the engineering design process for that mission. So I'd give the kids the student handouts that are provided, and it would walk them through thinking about the materials that they would use. I'd show them in the classroom what we were going to be using the next class period to build it, and then talk as a class or in their teams about some brainstorming of how they're going to solve that problem with those given materials, and then draw out some designs. Now, for the second class period, they would get their handouts back. They'd have to look at their designs and then bring them to me, present them as individuals or as their team that had their labeled design that's labeled with the materials they're going to use to get approval from me before I gave them the materials to start building.
Oh, that's a good idea.
Yeah, so the second class period was devoted to actually building and then testing their design idea for each mission.
Did you feel that those two 45-minute classes was enough time? Because that's the biggest question I get. How much time do I need for this curriculum?
So it worked out really well. Of course, I wish I had more time. I think that it would have worked better if I had more time to build up the storyline and be able to expand on the science concepts for each mission. But we did accomplish each mission in those two 45-minute class periods.
I've been telling teachers that about 2 hours is the ideal time if you can have it. And so maybe having a third 45-minute class devoted would probably have been a little better because I feel sometimes you were complaining you ran out of time on a few of the missions, right?
That's exactly right. And it's hard because my class periods were broken up. I think if you had a dedicated big chunk of time, it'd be
Right.
easier because, if the next class period, it took, 5 to 10 minutes to get back into things again. So yes, I think if it was done an after school program where you had a dedicated 2 hours, or even if I met 3 times, like you said, 3 times a week would have been helpful.
Also, since you had shorter class periods, my understanding is you didn't have the kids directly use all the platforms. So can you kind of tell me how you used Flipgrid and Goose Chase?
That's right. So I would film the kids doing their things for each mission on my own phone, and then I would upload videos later. So they didn't actually get to interact with Flipgrid themselves or do Goose Chase themselves. I would give them paper copies of the Goose Chase questions that they would have to do on their own time and then bring it to class. So that worked really well. And then I would submit them later so it didn't take up class period time. So if I were to do it again, I wish that I would have more time for the kids to actually submit their own videos on Flipgrid and interact more on Goose Chase themselves so they could get that experience, because I think it adds a whole lot of value that way.
Right. That's the feedback I got from a lot of teachers was the goose chase especially. They could see the points that their team was getting, the leaderboard of the other schools. And so I would encourage teachers to really try to find a way to use that goose chase app. Flipgrid, it really helps if you're distance learning. And so if you're stuck at home and you're not connecting with your classmates, that way you can see the other kids' projects. But since you're in the classroom, I feel like maybe it was okay that you didn't necessarily use Flipgrid. Do you agree?
I do. I think that I would have liked to have connected more with the parents using Flipgrid so they could see what their kids were doing in the classroom. I think that would have been the advantage of using Flipgrid in person, is
Hmm.
to get their families more involved and seeing the amazing things that the students were doing in my class. But I did share with them on Goose Chase. Each time they would come in, they would always ask, what's our ranking? How are we doing with the other schools? And so that was always really exciting. And I did share that with them, even though they weren't interacting with it in person.
All right. So when you ran this program, I know you went through the teacher training just like every educator. Can you talk about how much prep work was required to prepare your students and yourself for the curriculum?
So I was not familiar with the platforms of Goose Chase and Flipgrid, but just watching the training videos was extremely helpful for me and prepared me to use those. I was familiar with the curriculum, but I think that just having all the handouts, everything was really well prepared already for me. So as soon as I got the materials, it was kind of just a plug and play. I really didn't have to do much prep work besides dividing out the materials I would use for each week. And the handouts were really easy for the students to use. So it really didn't take much prep work for me. I would advise teachers that haven't done this before to go through the missions and maybe even try out building the missions themselves, building the different devices themselves, just to see based on their students' ability level where kids might trip up. Because I know they would get frustrated with some of the builds that were more challenging. And it'd be good to know that on the front end as you're going through that as well, just like any lesson that you teach in
Right.
the classroom.
Did you go through it week by week? The go
Yes,
through the build? Okay. So like if you were doing rovers, you would sit down and build a rover yourself just to kind of see what it would look like.
exactly.
Did you need to do a lot of differentiation between the different grades?
I didn't. In fact, my fourth graders did better than my sixth graders. So it
Interesting.
just, you just never know, but they did great with it. I know a lot of times this curriculum is used in middle school, but my elementary school kids did fantastic with all the designs.
Oh, that's awesome. You mentioned that your students were a little frustrated with some of the missions. Can you talk about maybe some of the missions that you want to tell teachers, hey, watch out for this. Here's some tips on how to avoid that.
Sure. So I think some of the most challenging missions were ones that kids didn't have something that they'd seen and that they could relate to more. So for example, the easiest one and the one that they probably loved the most was the roller coaster challenge, just because they are all familiar with roller coasters. They kind of know what they look like. It's a really fun build. It's easy to test as you're building it to see if things are going to work. Does the ball keep rolling?
Right.
So pretty intuitive stuff there. Where they would get hung up on is things that had to deal with like circuits or using the motor and the battery, things that they'd probably never done before. And so they'd get frustrated with this new technology that's also attached to building something. So it's just a lot coming at them at once. So it was helpful to kind of break it down and be like, okay, step one, let's see if you can get your motor on the rover challenge to just vibrate. So are you attaching it correctly to the battery? Everybody do that first. And then everybody's like, oh yeah, I see how it moves. It's like, well, you see when you just attach the motor to the battery and put it on the table, it vibrates and starts moving. You want it to still do that. Now design your body and attach what you just made work and see if it still works. So I think just breaking it down into bite-sized chunks of where their understanding is of how things work is really helpful.
And that's great feedback. We actually modified some of the handouts for the students to be more of a checklist. And so for that rover one, that's exactly how the teachers can walk them through it. Does the motor turn on? Step one, right? Versus doing different trials. So I think that's really good feedback. What was your student's favorite challenge?
Roller coaster by far. They would get
Really?
so excited. And that's the one where they would not want to just meet the requirements, which was like, does your roller coaster roll down and then fall into a cup? Add one turn. Like I had them like making loop-de-loops and all sorts of stuff. So they loved that challenge.
And we already talked a little bit about this, but can you give us some insight on how you use the engineering design process through this curriculum?
So the handouts work really well in walking students through the engineering design process. I would always have them brainstorm. We did a lot of brainstorming out loud, like as a whole class. And I kind of did that a lot at first. And then towards the end of Space Club, they would do them in their teams because they kind of understood how it worked. So I'd like hold up materials and be like, how could you use this material in your design? And then think about, well, what is it that you need to accomplish? Are there any materials that would help you with that before we started designing? And then often, even if they're working in teams, they would do the design step individually and then come together in their teams and talk about, okay, well, oh, I like this part of your design. Let's see if we can put both these design ideas together and then start building. And I'd always have them bring me their designs and get approval before they would be able to start building to make sure you're keeping them on track and staying in the process and not getting ahead. Because then they would get really frustrated if it didn't work. I was like, well, did you have a good design?
Right.
Did you really think through your materials first, or were you just grabbing things that looked cool and then gluing them together?
So did you have a materials table, or were they given a kit of supplies to work with?
I had a materials table. We have a maker space in my classroom. And so I actually had more materials for them to use than sometimes were listed on the materials that they have available on the handouts. But they were always kind of the same. Like if it said paper, I'd have like newspaper as well, construction paper, cardstock. So nothing too extreme, but they would have to only send up one person per team to get it. And they had to have them labeled in their design. So they weren't just like, oh, I'll need all of this stuff. It's like, no, you're just grabbing things because you think you need it all, but you don't,
Right.
you're not really going to use it. So we had to be mindful in the materials that we use.
A note here for the welcome tower, that's one that, did you constrain materials there? Because that one I feel some of the teams was too easy. They would just pick random materials and stack them and create a tower, when our intention was to constrain the materials. It was a harder challenge.
Yes, and I learned that through building it, because at first I had cups as one of the materials, and all of the kids did the same thing. They would stack cups, and that's what their tower would be. So I said, no, no more cups. You need to figure out a way to make a tower out of something else that doesn't stack so easily. So yes, constraining materials I think is always a good thing instead of giving them unlimited supplies.
Right. It forces them as a design constraint, right, to think more critically.
Mm-hmm.
What did your students think about the career chats, which also included the raffles at the end?
Career chats were an amazing way to bring in real world engineering. They started to really connect what they were doing in their missions with what is in the real world. So I think that was a fantastic way to bring a lot of additional stuff to their missions. They were really excited about the raffle prizes, of course. You know, they wanted to see that their hard work and answering their problems and the questions on Goose Chase was paying off. So even though we didn't win any of the weekly raffle challenges, the kids are always really excited for all the ways that they could keep being motivated to keep going. And they really got into seeing their questions answered in the career chats. I think that was huge because they would really think about it, because there were questions based on what the different people's like hobbies were and as well as their job experience. So they'd really start connecting what they were doing to these people's jobs as well. So, oh, you know, if they work for NASA, have they ever done this thing that I'm working on right now? And, you know, have they experienced zero G in the way that I'm building this roller coaster to experience how you train to be an astronaut? So loved those.
That's awesome. What about the student highlight videos? And we pulled clips from some of the top designs. Did they get to watch those?
They did, and they thought they were famous and considered themselves YouTubers, which is all of their dreams, right?
That's so funny. Well, I'm glad that worked. So we'll definitely be doing all of those components for the spring mission. Okay, so my final question is, what advice do you have for teachers that are wanting to do this now in the spring? So if you were to do it again, is there anything you would change or advice you can give?
I think what I would do differently is do more. So if I could do it again, I would really hype up the storyline, especially. And before Space Club even starts, I would start talking about what does it take to be a real engineer and scientist? How would you become a NASA astronaut or engineer? And really start talking about this storyline that can continue throughout the whole mission to the moon. And each day, maybe even like, I don't know if decorating my room would be that big of a difference, getting them excited about being there. Be like, okay, even though they say it in the intro video, which are amazing to get kids excited about what the missions are, but I would make the environment more conducive to that storyline line as well. Because the kids wouldn't get excited about where they were in the mission, but I think I could do better at
Yeah.
getting them excited about it. And their families as too. I wanted the whole school really to be excited about what was happening.
Yeah, and that's good input is really like hyping it up before you even start. And then kids are like in the mode. And then once they see that first like activity feed on the Goose Chase and they're seeing all these Space Club sites, it like becomes reality. And what's extra exciting for the spring mission is we can now say Space Club sites around the world are going to be participating because we had a group in England join us for the spring. So that's pretty cool to be able to be part of a program that you're not building stuff just in your classroom or at home, but it's connecting you to students everywhere doing the same projects. And I really like the feed because we never had the same exact design from a student. They were always totally different, out of the box, stuff I would have never imagined. The ones that shocked me the most, the robot hand was one where I was like, this is a really hard challenge, but let's see what they can do. And it was like incredible to see what these kids were coming up with.
Exactly. And what was really exciting is after I'd show those clips to my students, they would go home and they would do those challenges again in their free time
Oh,
using different ideas that they saw other students do because they're like, oh, I didn't think to do that or use that material. And so they'd get really into it. And that is also something that I shared with them. I said, the cool thing about organizations like NASA or being an engineer is you're not working just alone. You're not working in just your little team that you see every day in your office. This is an international collaboration. You're working for humanity. You're improving the world for all humankind. So think about what it means to be a scientist or engineer. You're solving problems for humanity, and see what you can do just as students, just as kids, doing something that kids around the world are also doing. That's pretty cool.
yeah, I love that. And then they get to actually connect with those real scientists and engineers that are doing it and asking their own questions. Um, we've talked in the past where when you were a middle school student, I think you were really nervous to talk to your role model astronaut,
Yes.
right? And so this is like we're giving kids the chance to ask the questions they've always wanted to ask for maybe someone they want to be like someday.
Exactly. I mean, it's an incredible experience that I think they will remember for a lifetime. And who knows, it could have been the thing that they look back on and say, oh, yeah, I became an engineer because when I was in this grade, I did this thing called Space Club. And I think that's the reality, but I think this will really make a big difference in how they view the world and what options are going to be available to them.
I love it. Well, thanks for sitting down with me and chatting about Space Club.
Absolutely.